This short video outlines the process of installing the Optimizer 2 on the HICO 145kV gas substation circuit breaker model HCSP 144B. Here are 18 HICO breakers ready for installation. Why add the Optimizer 2 to a new breaker? Today's breakers are so good that only a few measured parameters are needed to gauge their health. Using forecast info, gas refills can be planned when convenient and least costly. Gas emissions from leaking equipment can be recorded remotely and kept separate from handling losses. By assessing gas parameters remotely, the labor of a field inspection will be reduced. Begin by looking at the control cabinet. Look for a space that is easy to get to, easy to neatly run wires to, and close to the terminal block that terminates the bushing CT circuits. Preferably, the Optimizer 2 should be powered by station battery voltage, so that wiring should be accessible also. Some like to see the display through the cabinet window. This is often possible, but check to see that there is clearance so the cabinet door will close before you drill. The ideal way to connect the Optimizer 2 aux-A timing input is to connect it in parallel with the trip coil. This gives the best information and will include trip time, travel time, and clearing time, all key indicators of mechanism health. The aux-B timing input should be connected to wetted 52B switch or in parallel with the green light. With some modern protective relay schemes, trip coil monitoring is included. This protective relay function uses a very high impedance connection, which can be rendered useless if the Optimizer 2 is connected across the trip coil, even though the impedance of the Optimizer 2 is very high also. In this case, a separate trip output can be run from the relay that mimics the primary trip output. It should also operate when either trip circuit operates, if there are two. This output should be wetted with DC and a resistor placed in parallel with the Optimizer 2 aux-A input to minimize electrical noise. The simplest connection for the aux-B input is directly in parallel with the green light. The Optimizer 2 calculates primary current values from measurements on the secondary side. This makes it important to know the ratio of the bushing CT circuit you are connecting the pickup coils to. This value is entered into the Optimizer 2 as part of the setup process. The third step is to decide how you will connect the gas density sensor to the plumbing of the breaker. The sensor is always 3/8 inch British standard parallel pipe thread. The simplest connection to the HICO is to connect to one of the 3 DILO fittings, as you will see. This is quick, easy, and gives a high integrity seal. Schedule the outage in advance so things go smoothly. If the crew shows up prepared with all the parts, installation generally takes less than 2 hours. Shown here is one of the 3 DILO fittings. There is one per interrupter. This is an ideal location as the gas density measurement this close to the interrupter will be of high quality and truly represent the conditions inside the breaker. When needed, Dow 111 silicone sealant is recommended for threads. Dylo manufactures a special fitting for this purpose. For a DN8 connection, as shown here, use the Dylo part number SK372R006. The Incon gas density sensor will mate to this connector with the included rubber O-ring. The sensor is shown here, ready to connect to the breaker with the associated wiring harness. Standard quarter 20 bolts are ideal for mounting the Optimizer 2 enclosure on the rear of the control panel. Mounting the Optimizer 2 is easy. Often, it is possible to place it behind the window so it can be seen with the door closed. Field crews like this. Also, clean up the metal bits before you make gas connections to prevent impurities from getting into the gas system. Identify the bushing CT circuits and place the current pickup coils around those conductors. This CT ratio, referred to 1, is programmed into the Optimizer 2 when you set it up. Refer to the wiring diagrams provided by HICO for exact ratios and identifiers. Access to the control wiring is at the right side of the control box, as shown. Here, the aux-A input was connected to terminals TB3 and TB4 on block MC. The aux-B input was connected to terminals A54 and A55 on block MAA. Check the wiring diagram for details on your specific breaker. Programming is most easily done at the office before you take it to the field. The Optimizer 2 ships from the factory with default IP address. Use an Ethernet cable to log into the box using a web browser. Setup is easy. Most parameters are selected from pull-down menus. This part of the screen selects values that measured times are compared to for alarm purposes. This part of the screen sets up the SF6 density parameters. Here, the warning and lockout limits for SF6 gas are entered along with the sensor type. Digital true density sensors are standard with the Optimizer 2. But analog temperature compensated pressure sensors giving a 4 to 20 milliamp output can also be used. The Optimizer 2 offers many benefits. It will totalize the lifetime use of SF6, making EPA reporting compliance easy. It will obviate the need for offline circuit breaker testing. First trip information will show any degradation in performance over the years. Lastly, it migrates the SF6 system integrity function toward the active and predictive smart grid realm. Thank you. If you have questions or need more information, please contact Incon Power Reliability Systems at 800-872-3455.